A very common question is, where does the quadratic formula come from? So in this video we will be looking at it step by step. To be able to follow along with this, you have to be comfortable with changing the subject of the formula, dealing with fractions, dealing with surds and square roots, and crucially completing the square. So we have a quadratic equation, a generalized quadratic equation, ax squared plus bx plus c, where the coefficients a, b and c can be used in the quadratic formula to find the roots of this equation when we solve for x. And we want to know, how can we change the subject of this formula, rearrange it, to give us an expression for x? And it's difficult because we have both an x squared term and an x to the power of 1 term in here. So let's go ahead and have a look at this. First of all, we have an a coefficient in front of the x squared term, so the leading coefficient may not necessarily be 1. So what we can do is divide throughout by a, because this will then cancel out the coefficient of the x squared term, and 0 divided by a is just 0. So what we're left with is x squared plus b over a, x plus c over a. Now yes, they are fractions, but we can still deal with these quite easily if you are comfortable using fractions. So now we'll do a bit of rearranging. Let's subtract c over a from both sides to remove it from the left hand side here. So this becomes minus c over a, and c over a minus c over a, well, they cancel out to 0. Now we'll inspect the left hand side here. We have an x squared term plus a coefficient of x. So this is where we can use the completing the square. Because we have x plus pl squared plus q, we can write this into that form. All we have to do is figure out what are the values of p and what are the values of q. Well, we know from completing the square that to find p, we take half the coefficient of x. So for the value of p, let's take the coefficient of x and let's half it. And so we've got b over 2a for p. Now we want to find q. Because this equation, x squared plus b over ax, that could be plus 0. And when we square this, we're not going to have a 0 term. And so we square half the coefficient of x. And then we have to subtract that. So q is minus b over 2a squared, which is b squared over 4a squared. Okay, and now we have this equation in the completing the square form, so we can just remove that now and deal with this. Now we're going to do a bit of rearranging still, so we can get minus b squared over 4a squared to the right hand side by adding that to both sides. And now these cancel out. Alright, so we're not too far there. We've got minus c over a plus b squared over 4a squared. We can just shuffle this around, so we've got the b squared over 4a squared fraction leading. And now what we're going to do is we're going to combine these fractions, and we have to find a common denominator. So what would you have to multiply a by to get 4a squared? We'd have to multiply a by 4a. So you'd have to multiply top and bottom by 4a. And now we've got the same denominator. And we combine those. Now we've got b squared minus 4ac all over 4a squared. We're not too far away. Now on the left hand side we've got x plus b over 2a all squared, and we want to get x on its own. So we can take the square root of both sides, because this gets rid of this square term here. And we can just remove the brackets. And we're so close now. We've got x plus b over 2a on the left hand side, so we can just subtract b over 2a. But before we do that, we have to remember something. Let's have a thought experiment. If I was to say to you x squared equals 4, what would your solution to x be? Well, you'd say, well, x is equal to 2. But we actually have two solutions to this. We have indeed x equals 2, but we also have x equals minus 2, because minus 2 squared is also 4. We've got two solutions, a positive solution and a negative solution. So we can write that x, the solution to this x, equals plus or minus 2. And so we could also say that x is plus or minus the square root of 4. So we need to have the plus or minus symbol in front of the square root, because there are two solutions, a positive and a negative. And so we need to do that in front of our square root here. And now we can subtract b over 2a from both sides. These cancel out. Now we've got x on its own. But we're not quite there yet. This is the right answer, but we need to tidy this up and get it into the form that we're familiar with. And we want to do this by combining the two fractions. And we need the same denominator for that. And we need to somehow deal with this square root. Now if I said to you, the square root of a over b could also be rewritten as the square root of a over the square root of b, would you recognise that we have something similar here? Because here this could be represented by the a term, and the 4a squared could be the b term. And so we could represent this with as a fraction of two square roots. We've got the square root of b squared minus 4ac over the square root of 4a squared. And the reason we do this is because the square root of 4a squared is 2a. And we've got the same denominator, and I'm just going to swap the minus b over 2a to this side. And now I'm going to combine fractions. And now we have the quadratic equation that we're familiar with. And we can use this to find the roots of any quadratic equation, as long as we know the a values, the b values and the c values.